Hello everyone, welcome to the channel. In this video we'll try to improve one of the model that we fine-tuned earlier. This is the confusion matrix for image classification model. As you can see, the model isn't that accurate in predicting classes yet. It achieves an accuracy of 50%, while the one fine-tuned by colab AI scored almost 100% accuracy. It does so well because it was trained on large resolution and a huge dataset for much longer. I fine-tuned a new model with larger resolution and some additional configuration changes for 5 epoch. It's much better than previous model at classification, with 85% accuracy. In this video I'll try to improve its performance even further. In the paper they discuss the pre-training goal and using token sequence structure that is JSON convertible. Since the model predicts token sequence even for classification, we can use the same methods to fine-tune model on any downstream task. We'll use a simple metric for JSON comparison to calculate the accuracy, and not the one mentioned on the paper. In the setup section, they mentioned the learning rate used for pre-training. This is very useful information when fine-tuning the pre-trained model. They also reported that large resolution images gives better results. Let's begin. Here we set the max length for class prediction and resolution. You can add jitter to images for augmentation if you have fewer samples. Let's say we don't know the learning rate used in pre-training. Then we have to find it by ourselves. Set small number of steps and monitor log. We already know the learning rates used in pre-training the model. So for demonstration purpose, we can use lower or higher than that, and monitor its effect on loss. Let's first use a very low learning rate. Now monitor the loss. As you can see, it minimizes the loss but slowly. We can go with this learning rate, but it will take more time and steps to converge. You can increase the learning rate a bit, and monitor the loss. The loss is not so smooth because it's loss for each sample, and not the whole dataset. Now let's train the model with much higher learning rate. The loss just keep bouncing. You will even notice large loss and some weird behavior too. Setting a higher learning rate makes fine-tuning unstable, so you might want to lower it a bit. A safe strategy is to start small and increase a bit for faster convergence. You can find suitable learning rate on paper, GitHub repo or Hugging Face model documentation. When learning rate is just right, you'll see loss decreasing slowly and smoothly. I'm printing in every optimization step, but still you can see loss fading away slowly. Here's a quick guide to choose mini batch size. Choose a batch size, such that the model sees complete dataset in many steps. This helps in avoiding overfitting and better generalization. Now instead of modifying whole model weights, we'll freeze the encoder part that generates image embeddings. We'll also reduce position embedding table, since we only need 8 tokens, to correctly classify image. That's all we need to change. Now let's continue fine-tuning earlier model to improve even more. Let's look at loss for the model that I fine-tuned earlier. If your train loss is low and validation loss is high, this means model is overfitting. If both loss are high and difference between them is not that much, that means underfitting and models needs to be trained further. In a good learning setup, you'll see low train and validation loss, and the difference between them is also low. Let's check accuracy of the model. Confusion matrix is improved. If we have used the same resolution as the pre-trained model, it would have been even better. We achieved the accuracy of 93%. Precision score per class is good. Further training could improve the model accuracy even more. Note that this model was trained for a total of 8 epochs and not 3. So that's all for the video. If you liked the video, don't forget to subscribe to my channel. Thanks for watching, see you in next one.